Hello everyone, my name is Hadley. I'm an online tutor here at EOP, and in this video I will talk about the atmosphere. It is a video, so feel free to pause the video at any time to make sure that you understand every one of the concepts that I go over. You should be familiarized with all these concepts before you go up and face the AP test. So let's see, the atmosphere. First, let's go through its compositions. It is composed of mostly nitrogen, 78%, oxygen, 21%, and the rest are really small amounts. Water vapor, just from 0 to 4%. Carbon dioxide, methane, nitrous oxide, and ozone are still there, but their values are insignificant. The structure of the atmosphere. Down here, the closest to the Earth, we have the troposphere. Then it's the stratosphere, the mesosphere, and at the highest layer is the thermosphere, which is also called the ionosphere. Weather is caused by the movement or transfer of heat energy, which influences temperature, air pressure, humidity, precipitation, cloud cover, wind speed, and direction. Energy can be transferred through radiation, conduction, and convection. The climate. What are some of the factors that influence the climate? There are plenty of them, like air mass, air pressure, albedo, altitude, angle of sunlight, clouds, distance to oceans, fronts, heat, land, latitude, location, humidity, mountain ranges, pollution, rotation, wind pattern, and of course, human activity. Atmospheric circulation and the Coriolis effect. Well, we know air closer to Earth's surface is the warmest, and it tends to rise up. And then air at higher elevations is cooler and more dense, so it sinks. So at the bottom we have the warm air, on top we have the cold air, and then they basically swap positions. Global air circulation is affected by uneven heating of Earth's surface, seasons by the Coriolis effect, which we'll talk a little more about it, amount of solar radiation reaching the Earth over long periods of time, convection cells created by warm ocean waters that commonly leads to hurricanes, ocean currents, winds, and Earth rotation. These are things that affect the air circulation around the globe. Horizontal winds move from areas of high pressure to areas of low pressure. So wind moves from high pressure to low pressure. And the greater the difference between the two pressures, the faster the wind would travel. Wind speed is determined by the pressure difference between air masses. Wind speed is measured with an anemometer, and wind direction is measured with the wind vane. Here's the Coriolis effect. It is Earth rotation on its axis, causing winds to not travel straight. And the worldwide system of winds, which transports warm air from the equator toward higher latitudes where solar heating is diminished. It gives rise to Earth's climatic zones. There are 3 types of air circulation associated with latitude. Again, they are associated with, their latitude with respect to Earth. Hadley air circulation cells, Farrell air circulation cells, and polar air circulation cells. And we're going to talk a little more about each one of these. First is Hadley air circulation cells. They are characterized by high humidity, high clouds, and heavy rains. Their monthly average temperatures are around 90 degrees at sea level. There is no winter. Vegetation is tropical rainforest. The temperature variation from day to night is greater than variation from season to season. So the temperature changes more throughout the day than throughout the seasons. Now, the second circulation cells, the Farrell air. Mid-latitude climates can have severe winters and cool summers. Climate is governed by both tropical and polar air masses. Seasonal fluctuations of temperatures greater than the change in temperature occurring in a 24-hour cycle. Broadleaf, deciduous, and coniferous evergreen forest. These are characteristics of the Ferrer air circulation cell. And the last one, polar air circulation cells. So polar cells originate as icy cold, dry, dense air that descends from the troposphere to the ground. Polar regions are deserts. Very little water exists in this area. Amount of snowfall per year is relatively small. Climates characterized by low temperatures, severe winters, and small amount of precipitation. The annual fluctuation of temperature is greater than the change in temperature occurring in a 24-hour cycle. So as we saw before, for the Hadley air circulation cells, temperature tends to change more during the day than throughout the year. But for the third type, for polar air circulation cells, it's the complete opposite. Temperature tends to change more throughout the year and the seasons than during the day. And two major biomes exist: the tundra and the taiga. Hurricanes and tornadoes. Hurricanes are the most severe weather phenomenon on the planet. They begin over warm oceans in areas where the trade winds converge. A subtropical high-pressure zone creates hot daytime temperatures with low humidity that allows for a large amount of evaporation. The Coriolis effect initiates this cyclonic effect. Again, the Coriolis effect is what causes wind to not travel in a straight path. You know, it starts to curve and then eventually turns into a hurricane, or it could potentially turn into a hurricane. So that's it for the atmosphere. Feel free to ask any questions. If you do have any questions, email us at the email address that's written on the description of the video, and we will answer back as soon as possible. Thank you.